Hi, my name is Sarah Patton, and welcome to our chemistry project vlog. Today we're going to talk about electrochemistry, but first let me introduce myself and my teammates. I'm a senior at Appalachian State and Caldwell Community College. My major is nutrition, and I'm graduating in 1 week. Next is Joey.
Hi, I'm Joey. I am also a senior at Appalachian State, and I will be graduating in the fall semester of 2019, as well as graduating from Caldwell Community College this semester. A little bit about me. Chemistry actually has a lot to do with what I want to do in my life, as I do want to go to PA school, so learning about how electrons move also relates to the body, so this is a lot of useful information that I'm sure a lot of you guys will utilize in your career fields. And I hope you guys are going to learn as much from this as we learned from it. And I'm going to also introduce our good old buddy Mason over here.
Hey, my name is Mason Calloway. I'm a junior at Appalachian State University and also Caldwell Community College. Been here for 2 semesters now. My major is nutrition and dietetics. Do I regret it? Possibly. So I'll go into a couple hobbies and things I like doing. I really enjoy hunting and fishing. Those are both really fun. I really like weightlifting. I have a passion for that. I'm here at Caldwell Community College because I failed chemistry twice. So that's one of the reasons why I'm here. It's going really well. But this is our intro, and we will get on with our experiment. So for the experiment today, we'll be talking about oxidation and reduction.
Hey, my name's Joey, and today we're going to be talking a little bit about electrochemistry. You might be asking what electrochemistry is. Electrochemistry is the relationship between the electrical and chemical components dealing with electrons and the movements that they have in common with each other. The movements of electrons is called electricity, which is where the electro comes into this. And what that is electrons can move, electrons can either gain or lose. Whenever an electron is lost, it has a raised oxidation. And the opposite is also true. When an electron is gained, it will lose its oxidation rate slightly. And now we're going to have Mason give a little bit more as to what losing and gaining electrons and the oxidation rates actually mean.
Hey, my name is Mason Calloway, and today we're going to be talking about reduction reactions. So, basically, we can ask ourselves, what is reduction reactions in chemistry? In its defined definition, reduction is a chemical reaction that involves the gaining of electrons by one of the atoms involved in the reaction. The term refers to the element that accepts the electrons, and then as the oxidation state of the element gains electrons, the oxidation state becomes lowered. So, when we think about this, we can ask ourselves, what is an example? One example could be the formation of hydrogen fluoride, which in that state it actually gains electrons, and then another example would be the formation of hydrogen fluoride, which also gains electrons. The reaction can be broken down to analyze the oxidation and reduction of reactions. The hydrogen is oxidized and loses 2 electrons, so each hydrogen becomes positive in that example. And then we can ask ourselves the differences between oxidation and reduction. So as Joey explained in the last video, oxidation is when the electrons are lost, and then reduction is when they are gained. But when we look at the key differences, reduction occurs when an element gains electrons and its oxidation number actually decreases therefore it's reduced. And then when we look at the oxidation number increases and the element loses electrons or becomes more positive. We're going to go on to demonstrate this with two different kinds of metals. We're going to use copper electrodes and a zinc electrode.
Hey, I'm Sarah Patton, and I'm going to be showing you our experiment. So, over here, we have our voltaic cells. As you can see right here, we have zinc, our zinc electrode, which represents this bar. It is in the zinc sulfate solution. And then we have our copper electrode, which is this bar, in our copper sulfate solution. The electrodes are connected by a closed circuit and are neutralized by our salt bridge. Over here, our spheros represent our electrons that are going to be moving throughout the experiment. The voltaic cell consists of two half cells. The half cell where oxidation occurs is the anode, which is our zinc, and the half cell that reduction occurs is our copper. Yeah.
Okay, so what we did for our experiment is we wanted to show the difference between oxidation and reduction. One way we thought about doing this was to replicate two different metal electrodes, and we would show how one of these little things called spheros would be used to simulate this. So one thing that we did was we downloaded this app called Sphero EDU. This is the programming that we did for it. So if you watch closely, what we can do with programming is we can set a predetermined program into it, and then when we push start, it actually travels. Okay, so what we did for our experiment is we wanted to show the difference between oxidation and reduction. One way we thought about doing this was to replicate two different metal electrodes, and we would show how one of these little things called spheros would be used to simulate this. So one thing that we did was we downloaded this app called Sphero EDU. This is the programming that we did for it. So if you watch closely, what we can do with programming is we can set a predetermined program into it, and then when we push start, it actually travels. Hold on.
This video shows our spheros, which represent our electrons, are going to travel from the zinc electrode to the copper electrode, representing zinc becoming oxidized. And they're going to travel in 3, 2, 1.
As you can see, the electrode started out on the side of the zinc, but the electrons were then shared and they are now at the copper side. This is a little process called oxidation, and as you can tell, the zinc was oxidized because it was losing electrons. And one thing that it did was it was giving it electrons, which started over here, and now the electrons are at the copper, therefore it was sharing its electrons. Now you can see that zinc is now going to have a higher oxidation number because of the losing of its electrons. And the oxidation is also increased in this reaction. It's also going to become more positive because of the losing of electrons. And the program that we used for this was 0 degrees at a 47 speed for 1.5 seconds. And now I'm going to let Mason talk a little bit about what a reduction is.
Okay, so I'm here to talk about reduction. So as my counterpart, Joey, or Joel as we'll call him sometimes, just talked about, he did zinc, as you can see. I'm going to do copper. So what we did earlier in the experiment was you can see that one of the electrons, or the spheros, or whatever you want to call them, traveled from one side to the other. So since the copper is a reduction reaction, this means that it was gaining the electrons. So the zinc lost some of the electrons and the copper gained them. This was simulated earlier. Another thing that we can look at is that it accepts electrons from zinc, which is what I just said. So we'll go to the next part. So when that happens, what happens is the oxidation number decreases and the oxidation is reduced. And as this happens, the copper, or our reduction reaction, becomes more negative.
In conclusion, we wanted to show the math to our oxidation and reduction reaction. We can see here that zinc is losing 2 electrons And so copper down here is gaining 2 electrons. And this is the equation that was created by our spheres and electronegativity.